Greetings, Internet users. We have seen many images of the planets, but very rarely do we know if what we are seeing is entirely real, if it has been manipulated, or if it has been filtered. New research from Oxford University has corrected some of the images of the planets Uranus and Neptune taken by Buer in the 20th century and found that much of what we knew about these planets has been reinforced with other colors. Today, you're going to see the latest unpublished images you didn't know about some of the planets in our solar system. And not only that, you're also going to discover the surprising changes that planets with dense atmospheres undergo over time. Our journey takes us to the outer solar system, home to Mars, Jupiter, Saturn, Uranus, and Neptune. For decades, the real appearance of Mars has caused much controversy. Mars is known as the red planet due to its characteristic red-orange color, which is visible to the naked eye from Earth. This color is mainly due to the presence of iron oxide, commonly known as Aurora oxide, on the planet's surface. This iron oxide gives Mars its reddish hue. Photographs from NASA, the ESA, and other sources have only added to the perplexity, from the black and white photographs of the Mare 4 to the reddish ones from the Viking rovers to the current rovers. The appearance and color have been changing. We've seen blue skies on Mars, but what is the reality? The planet has a surface with a variety of geological features, including plains, canyons, mountains, and craters. Some areas are lighter in color, while others have darker tones. The visual appearance of Mars can vary depending on various factors, such as solar illumination, atmospheric conditions, and the presence of dust storms. Space missions, such as those carried out by NASA rovers like Spirit, Opportunity, and Curiosity, have provided detailed images of the Martian surface and contributed significantly to our understanding of the planet's geology and atmosphere. For decades, it was thought that the color of the surface and sky was dark red, but the truth is that it looks a lot like some of the deserts on Earth. Here's what Mars looks like according to the Chinese probe Tianwen-1, very similar to NASA's rovers. The color of the surface is ochre and can vary from beige to dark brown. The sky is salmon-colored most of the day due to its thin atmosphere. Clouds are barely visible and sometimes the sky turns blue, but this occurs at dusk, a phenomenon known as lightning scattering. On Earth, the atmosphere scatters sunlight in all directions, but the scattering is more efficient for the shorter wavelengths, such as blue and violet. This results in blue light being scattered in all directions, which makes us feel the blue color of the sky. On Mars, the atmosphere is different, and although it contains dust and particles, it can also scatter sunlight in a similar way. During the Martian day, when the sun illuminates the atmosphere, the scattering of blue light can make the sky appear blue. This is what Mars looks like as seen by the James Webb Telescope. The telescope can't capture real or near-real images as it is an infrared telescope, but it can capture more detail to study phenomena such as dust storms, weather patterns, seasonal changes, and other events. An example of this is the analysis of the surface by Perseverance's Sherlock instrument, which made it possible to analyze the composition of Martian rocks from different spectra. Together with the Watson camera, Sherlock was able to detect the spectral signature of organic substances in some rocks. Mars undergoes seasonal changes and sometimes turns yellow due to dust storms that can last for weeks. Mars may undergo many other changes, but what we know for sure is that its satellite Phobos will fall. The Martian atmosphere is expected to turn into a ring in 10.4 million years. However, before that, in about 7,600,000 years, when it is only 3,620 kilometers from the surface, it will be destroyed by tidal forces, creating a ring. If we're still here, which is highly unlikely, we'll see Mars become a planet with a ring. Moving on to Jupiter, I present the image from the OX2 probe, very similar to the real thing, but with a slight contrast. This is followed by the image from the Hubble and James Webb Space Telescope in the infrared spectrum. We come to the spectacular images captured by the Juno probe of Jupiter. These images look like watercolors, like a painting. However, the reality is that almost all of Juno's images have been processed altered, and manipulated to better capture the details of the planet. If we were there, we wouldn't be able to see so much detail on its surface. The image highlights a reddish storm 20,000 kilometers from the surface, with winds of up to 150 kilometers per hour. It's important to note that Jupiter doesn't have a solid surface, but three layers of clouds of different composition. The white colors are ammonia, the brown ones are ammonium hydrosulfide, and a lower layer of water clouds. The red colors are due to the presence of organic compounds. The reality is that if we were there, we wouldn't see any of this with such enhanced colors. The clouds wouldn't be seen with such high resolution if it weren't for the filters and the different wavelength spectra. We would miss out on great wonders of the cosmos. Another significant fact is that Jupiter is changing its appearance slightly. The Great Red Spot, a large anticyclonic storm, has been shrinking for the last 150 years. That's how OX2 saw it 40 years ago, and that's how it looks now. Jupiter will continue to experience changes over the next million years. The Sun is undergoing changes over the next million years, the most significant of which will be an increase in its size and radiation as it ages. Currently, Jupiter is dominated by its internal heat, but in 5 billion years' time, Jupiter's cloud bands will be much narrower and the winds will be spinning very fast due to the incoming heat. Another important point is that some of Jupiter's satellites, such as Europa, could become habitable. Saturn is an incredibly beautiful planet, captured by viewer cameras with lots of contrast and exaggerated colors. This is how the Hubble Space Telescope captured it. Closer to our view, this other photograph is from the James Webb Space Telescope, in infrared. Cini's images look more like our view and reveal an orange world with a ring system. The clouds seem less significant than on Jupiter. Although their winds are often stronger than Jupiter's, up to 150 kilometers per hour, Saturn's clouds are usually more dispersed and are not found at different altitudes to Jupiter's. In addition, clouds on Saturn can be partly composed of water ice crystals, which can affect their appearance. The impressive transformation of majestic Saturn is a cosmic spectacle in constant evolution. In addition to the dramatic changes that lie ahead for its icy satellites, it is predicted that over billions of years they could potentially become habitable. However, an imminent fate awaits the iconic rings that embellish Saturn. In a relatively short time span of 300 million years, the rings will be inexorably drawn towards the planet by gravitational and magnetic influence. By studying Saturn, scientists have shed light on the relative youth of the ring system, estimating that it is no more than 100 million years old. We are therefore witnessing a cosmic rarity, an ephemeral beauty that enchants our fleeting existence. This phenomenon invites us to reflect on the transience of celestial events and to appreciate the unique beauty that Saturn offers us. On a more distant journey through the solar system, the exploration of Uranus revealed challenges and surprises. When the BEWER-2 probe reached Uranus in 1986, the initial images were disappointing, depicting a gaseous ice giant with no discernible details on its surface. The color palette, a pale blue-green, was all we could discern. However, technological advances exemplified by the James Webb Telescope have provided a richer and more detailed view, especially with the use of infrared resolution. The improved representation of Uranus, thanks to James Webb, allows us to immerse ourselves in details that were previously imperceptible. While previous photographs captured Uranus with faint rings and more muted colors, the new view provides an experience closer to the reality our eyes have witnessed. This contrast highlights the complexity and intrinsic beauty of this distant planet, redefining our understanding and appreciation of the cosmos. The meticulous work of Professor Irwin and his colleagues in analyzing the original images of Uranus captured by the BEWER-2 probe reveals fascinating nuances in the appearance of this distant gas giant. The detailed comparison, carried out in two different filters, 467 and 551 nanometers, with images from the Hubble Space Telescope's wide-angle 3 camera covering a period between 2014 and 2022 provides a more in-depth view of the planet's color palette. The results obtained indicate that the original images from Boer 2, especially in the wavelength ranges mentioned, remain surprisingly faithful to the true coloration of Uranus. The small discrepancy found suggests remarkable precision in the visual representations, consolidating confidence in the observations made by the probe. In addition, the research reveals an intriguing seasonal phenomenon on Uranus. The analysis indicates that the planet takes on a greener hue at its solstices, that is, during summer and winter, when one of the planet's poles is directed towards the sun. However, during the equinoxes, when the sun is on the equator, Uranus's coloration tends to lean towards shades of blue, providing a dynamic and seasonal chromatic spectacle. This more refined understanding of color variation on Uranus enriches our knowledge of the atmospheric and climatic complexities of this fascinating gaseous world, offering a more complete and detailed view of the characteristics that govern its planetary aesthetics. The intriguing twist in the perception of Neptune adds a fascinating layer to our understanding of the solar system. Over the decades, we have been presented with enhanced images of this distant gas giant, initially characterized by an intense, brilliant blue. However, the researchers' latest findings reveal a surprising truth. Neptune's true color is closer to that of Uranus than previously believed. NASA's editing techniques used to highlight clouds and spots on Neptune initially supported the perception of a deep blue. However, when examining images from the Hubble Space Telescope, scientists began to suspect a discrepancy in the coloration. This intriguing mystery led to further analysis, seeking to accurately portray Neptune's true color palette. Recently, the James Webb Infrared camera captured revealing images, displaying a wealth of previously unknown details. The refinement of the color to resemble the images from the Boer probe, combined with the brightness measurements recorded by the Lowell Observatory in Arizona between 1950 and 216 in blue and green wavelengths, led scientists to determine Neptune's real color. Surprisingly, contrary to widespread belief, the deep blue hue attributed to Neptune in many documentaries does not reflect reality. This revelation prompts reflection on the importance of accuracy in interpreting the colors of celestial bodies, highlighting how our perceptions can be shaped by visual representations over time. Neptune's true coloration not only redefines the planet's aesthetics, but also highlights the ongoing need to refine our understanding of the cosmos as new technologies and observations lead us to enlightening discoveries. The surprising revelation about the misperception of Mars over the decades highlights the importance of precision in planetary analysis. The confusion stemmed from the Boer probe's capture of the planet in 3 different colors, an approach that was unfortunately not compensated for with the necessary precision. Scientists, in their quest for minute details, far removed from aesthetic or realistic concerns, are redefining our visual understanding of Mars. Using data from the HLE Space Telescope's imaging spectrograph and the European Southern Observatory's Very Large Telescope's multi-on spectroscopic scanner has provided a detailed comparison between images of Mars and Uranus. The results reveal remarkable similarities between the 2 planets, debunking the idea of Mars as an intensely red planet. The scientific approach seeks, above all, to maximize the understanding of geological, atmospheric, and compositional characteristics, providing a more accurate view of celestial reality. Although Neptune still has a slightly bluer hue than Uranus, due to its high methane clouds that absorb the red color, the popular image of Neptune as a deep blue is being reconsidered. The truth is that Neptune is far from the intense blue color we have long believed. For its part, Uranus reveals its less bluish hue due to the greater thickness of methane ice particles, which are more dispersed in its atmosphere. These discoveries reinforce the constant need to adjust our astronomical perceptions in the light of more precise data and advanced technologies. The universe, always full of mysteries, continues to challenge and expand our pre-existing understandings, encouraging a deeper and more precise exploration of the cosmos. Professor and astrophysicist Katherine Hyman's observation highlights a crucial aspect in the interpretation of astronomical images: color adjustment. She points out that even scientists from 4 decades ago carried out a procedure that is now within everyone's reach. This brings us to an intriguing question. After all, what defines the true color in an astronomical image? It is common practice for telescopes and space probes to highlight features that would be imperceptible to our eyes. The real question lies in how we interpret and represent cosmic colors. The vast majority of images of planets, if observed directly, would appear to have extremely faint colors, hardly discernible by human vision. The evolution of our vision on Earth has been shaped to capture specific nuances of the immediate environment. But when we turn our gaze to the cosmos, we realize that our eyes are not adapted to grasp all the chromatic diversity. As we explore the nuances of this perceptual challenge, it dawns on us that our professional cameras and smartphones are designed to mimic our vision, with colors calibrated on Earth, taking into account its lighting conditions, atmosphere, and contrast. However, no matter how hard we try, it is impossible for any camera to completely capture the details and colors that our human eyes can discern. This reflection leads us to a deeper appreciation of the subjectivity inherent in the visual representation of the universe. Every astronomical image we contemplate is, in a sense, an artistic interpretation, an attempt to translate cosmic grandeur into an understandable visual language. In this context, science and aesthetics intertwine, challenging us to constantly reconsider the way we perceive and represent the vastness of the cosmos. A realistic appreciation of these planets, as it would be if we were there in person, remains an experience beyond our current capacity. The only true way to witness the grandeur of these worlds would be to be physically present. However, even in the face of this limitation, it is fascinating to consider that the balance and appearance of our solar system has been in constant transformation over millions of years. The natural course of renewal and evolution unfolds from spaceship Earth, slowly shaping the celestial landscape we behold today. Currently, our only way of contemplating the wonders of the cosmos is through robotic eyes or through filters that magnify cosmic wonders. Technology, combined with human curiosity, gives us an extraordinary view of these distant destinations, but always remembering that we are, in a way, vicariously present through these technological extensions. If the content of this video has piqued your interest, please consider expressing your support by liking and subscribing to the channel. Contributions on Patreon are a valuable way of keeping the channel active and sustaining the production of more informative and engaging content. Sharing on social media not only raises awareness, but also extends the reach of these fascinating cosmic explorations. Leave your comments below, sharing your thoughts or questions about the vast universe that surrounds us. Ultimately, every like, subscribe, comment, and contribution plays a vital role in creating a community that is passionate about exploring the mysteries of the cosmos. A cosmic hug to you all on a journey of discovery that transcends the boundaries of space and time.